This content is produced by PASS, the CSLB, an independent audio-first study companion for busy California B general candidates. I build these lessons from official CSLB study guide topics and reputable, source-backed California materials so you can study on the go. This is exam prep reinforcement, not legal, professional, engineering, or job-specific advice. Exam content is set by PSI and the CSLB and may change, so always verify current requirements against official CSLB materials. No exam outcome is guaranteed. Now let's get into it. Do not let the drywall schedule make the moisture decision. The central field principle is simple. The condition of the framing at the moment of enclosure matters more than what the lumber stamp said weeks or months earlier. A mill stamp tells you something about the board when it was manufactured. A moisture meter tells you what is happening now, on this job, before the framing disappears behind insulation, drywall, floor covering, or another finish. I think of enclosure as a one-way gate. While the framing is open, I can see it, test it, sort it, dry it, replace a bad piece, and correct a crown. After it is covered, the same condition becomes harder and more expensive to reach. Wet wood can continue drying and changing dimension after finishes are attached. That movement can contribute to nail pops, cracked joints, distorted surfaces, and callbacks. The useful supervision question is not, does the wood look dry enough? The question is, do current measurements and current conditions support enclosure? The statewide CALGreen rule in this lesson gives that decision a clear limit. Wall and floor framing must not be enclosed when framing members exceed 19% moisture content. The wording matters. 19% is the upper boundary for the enclosure decision. A reading above 19% means the framing is not ready to cover. A reading at or below 19% satisfies this moisture threshold, but it does not erase other inspection, plan, or approval requirements. The same 19% limit applies to preservative-treated wood in enclosed locations where drying and service cannot readily occur before insulation, interior finish, or floor covering goes on. I also want you to separate framing moisture from insulation condition. If insulation is visibly wet, it must be replaced or allowed to dry before enclosure. A dry stud beside wet insulation does not make the cavity ready. Looking at this reference, I want you to notice that every row asks the same practical question. Can this condition be covered now? Framing above 19% gets a no. Enclosed preservative-treated wood above 19% gets a no. Visibly wet insulation gets a dry or replace decision before the cavity is closed. Framing at or below 19% passes only the moisture part of the decision. I never treat that number as an automatic approval for the rest of the work. The reason this matters is not mysterious. Wood exchanges moisture with its surroundings. As wet framing dries, it can shrink or distort. If rigid finishes are already fastened to it, that movement can show up in the finished surface. I am not claiming that every wet board guarantees a failure. I am saying the condition creates a supported risk that is much easier to manage while the framing remains open. Imagine a contractor who finishes framing just before several days of rain. The roof is dried in afterward, and the schedule says insulation and drywall should start next. The tempting shortcut is to judge the studs by touch and keep the schedule moving. The better supervision choice is to measure. If a random reading comes back at 24%, the framing is over the CALGreen limit. The contractor delays enclosure, allows the framing to dry, tests again, and documents the later readings. That sequence protects the decision with evidence instead of optimism. My memory connection is this: 19 is the gate, not the grade. The gate controls covering today. The grade stamp describes manufacturing history. A moisture number is only useful when the reading is taken correctly. CALGreen allows either a probe-type moisture meter or a contact-type moisture meter. A probe meter uses pins that enter the wood. A contact meter takes a reading through contact with the surface. I do not need to turn this into a tool brand discussion. For exam preparation and field supervision, the important point is that visual inspection and touch do not replace an authorized moisture meter. The reading location is unusually specific, and that makes it worth memorizing. The measurement must be taken from 2 feet to 4 feet away from the grade stamped end of the lumber. I do not test right on the cut end. End grain can lose moisture faster than the face of the board, so an end reading may look drier than the body of the piece. That can produce an overly optimistic picture of the framing. The range gives me a clean memory phrase. 2 to 4 from the stamped end, not 2 to 4 inches. Not anywhere that is convenient. 2 feet to 4 feet from the grade stamped end. The sampling rule is also specific. A minimum of 3 random moisture readings must be performed on the wall and floor framing before enclosure. Minimum means 3 is the floor, not a promise that 3 readings are always enough to understand a large or obviously uneven project. The official baseline is at least 3 random readings, and the results must be documented in a format acceptable to the enforcing agency when approval to enclose is sought. I want to slow down on the word random. If I choose only the 3 driest looking studs near an open doorway, I have not made a credible sample of the framing assembly. The point is to avoid cherry picking. The research report supports the minimum count and documentation requirement. It does not give me permission to invent a private sampling formula for every project. I follow the required baseline in the enforcing agency's acceptable process. Consider a hypothetical wall with 1 sunny face and 1 shaded face after a storm. A contractor tests only a board beside the open garage door and gets a low reading. That single result does not satisfy the minimum, and it may not represent the wetter part of the work. The correct response is not to argue that the wall feels dry. The correct response is to take the required random readings in the required locations, record them, and let the current measurements guide the enclosure decision. There are 4 parts I want connected in your mind. Use the proper meter. Measure 2 feet to 4 feet from the grade stamped end. Take at least 3 random readings. Document the results for the enforcing agency. If one of those pieces disappears, the test record is incomplete. Now I want to clear up the mill stamp trap. A stamp spoken as ESS dry means surfaced dry. It indicates that the lumber was at 19% moisture content or less when it was surfaced at the mill. A stamp spoken as S-GRN means surfaced green. It indicates that the lumber was above 19% when it was surfaced. Those designations are useful receiving information, but they are not permanent moisture guarantees. Lumber marked surfaced dry can be delivered, stored in wet weather, and absorb moisture before enclosure. The stamp does not update itself. That is why the current meter reading controls the current field decision. This distinction is easy to lose because the same number appears in 2 different contexts. 19% on a surfaced dry stamp describes the board at manufacturing. 19% in the CALGreen enclosure rule describes the board when the wall or floor is about to be covered. Same number, different moment. I remember it as stamp then, meter now. The general B boundary is also important. I am not teaching detailed species grading, not limits or slope of grain calculations here. The field supervision skill is to verify that delivered material matches the plans and specifications, recognize the basic moisture designation, and never substitute a historical stamp for a current job site test. Moisture and storage show up again when lumber changes shape. Warp is the umbrella term for a board that departs from a true or plane surface. Crown, bow, cup, and twist are specific forms of that broader distortion. Contractors often use warp as a casual name for any bend, which is fine in ordinary conversation, but exam preparation benefits from the precise distinctions. I put the terms side by side because the direction of the distortion is what separates them. A crown, also called a crook, is an edgewise deviation from a straight line running end to end. Sight down the narrow edge and the board bends to one side. The convex side of that edgewise curve is the crown. A bow is a flatwise deviation from end to end. Instead of bending sideways along the narrow edge, the wide face humps or sags along the board's length. A cup runs across the width of the face, edge to edge, so the board resembles a shallow trough. A twist means the corners of a face no longer lie in the same plane because the board winds along its length. The vocabulary matters because each defect affects layout and finish differently. A mild crown may be managed through consistent orientation. A serious twist is a different problem because the board does not offer one stable plane. I avoid turning this into a universal accept or reject rule because the plans, specifications, grade, location, and degree of defect still matter. The supervision task is to identify the condition before installation, not discover it after sheathing or drywall makes the surface problem obvious. Here's a quick physical check. If the bend is sideways when I sight the narrow edge, I am thinking crown or crook. If the long wide face rises or falls, I am thinking bow. If the face curls across its width, I am thinking cup. If the corners wind, I am thinking twist. Warp is the family name over all of them. Crown orientation is where terminology becomes a framing decision. For horizontal members such as floor joists, ceiling joists, and rafters, standard framing practice is to install the crown up. The useful image is a slight upward hump waiting under a downward load. The framing and service loads act downward, so an upward crown works against that direction. Installing the crown down starts the member with the curve already moving in the same direction as deflection. I do not tell you that every crown joist will become perfectly flat. Lumber varies, loads vary, and unacceptable defects still need to be sorted out. The point is the orientation rule, crown up, gives the assembly the correct starting direction. Crown down can compound a low spot or sag. Suppose a crew is laying out 2x10 floor joists. One carpenter marks the high edge of each usable joist before installation. Every mark is kept up as the joists are set. That small step gives the subfloor a more consistent bearing plane. If half the joists are turned crown down at random, the deck can begin with alternating highs and lows before any finish load is added. Wall studs use a related principle, but not the same phrase. A vertical stud does not get installed crown up because up is already the length direction of the stud. For usable studs with moderate crowns, I orient the crowns consistently across the wall plane. All the curves face the same direction rather than alternating in and out. That consistency helps the sheathing or drywall follow one smoother plane instead of snaking over opposing humps. This is a common confusion. Joists and rafters get crown up because the curve is being managed against downward loading. Studs get crowns aligned in the same direction because the finished plane is being managed across the wall. Same defect, different supervision choice. Imagine a finished hallway under strong light from a window. If stud crowns alternate directions, the wall surface can show repeating waves and shadows. The drywall is following the framing it was fastened to. The missed decision happened before the board was hung, when the studs could still be sighted, sorted, and oriented. My memory phrase is short: floors fight gravity. Walls favor consistency. That keeps crown up separate from crowns same way. Lumber storage brings in a different set of numbers. California occupational safety and health rules limit lumber that will be handled manually to a stack no more than 16 feet high. The overall maximum height for a lumber pile is 20 feet. That higher number does not turn a manual pile into a 20-foot pile. Manual handling keeps the 16-foot limit. Mechanized handling may reach the overall limit, provided the pile is stable and the operation complies with the applicable safety requirements. I use the phrase 16 for hands, 20 for machines. It is only a memory aid, so I attach two cautions to it. First, 20 feet is the overall cap, not a target. Second, height alone never proves that a pile is safe. The pile must be maintained stable against falling or collapsing. The safety order calls for headers, cross pieces, or other stabilizing means at necessary intervals. In field language, you may hear cross pieces called dunnage or stickers. Their job in this context is to support stable stacking. A tall pile without proper support does not become acceptable merely because a tape measure shows a number below the limit. Consider a hypothetical delivery on a tight site. The forklift operator proposes a stack 18 feet high to save space. The crew will break the bundles and carry the lumber by hand. The manual handling limit controls, so 18 feet is too high for that plan. The superintendent directs the delivery into lower stable piles and confirms that cross pieces support the stack. That is a supervision decision before production pressure turns into exposure. Weather protection belongs in the same coordination conversation. I do not want lumber needlessly re-wetted after delivery, especially when enclosure is approaching. At the same time, I do not invent a single storage method for every site. The practical responsibility is to coordinate a stable storage area, protect material from avoidable wetting, and verify actual moisture before covering. Storage practice supports the meter result. It does not replace it. Housekeeping is not a final cleanup event. During construction, form lumber and scrap lumber with protruding nails must be kept reasonably cleared from work areas, passageways, and stairs. The wording "reasonably cleared" still creates an active duty. It does not mean debris can accumulate in the travel path until the framing phase ends. I want you to connect this rule to material flow. Lumber comes off the pile, gets cut, becomes installed framing, and produces offcuts. If the offcuts stay where workers carry the next load, the same material handling system creates its own obstruction. A protruding nail adds a puncture and snag hazard to the trip hazard. The supervisor's job is to keep the path usable as the work progresses. A clean passageway also makes inspection and defect correction easier. I am careful not to claim that housekeeping automatically produces approval. I am saying that clear work areas support safe access, accurate observation, and orderly correction before concealment. I now want to put the whole supervision sequence into one field rhythm. At delivery, I compare the lumber to the plans and specifications and read the basic moisture designation on the grade stamp. I treat that stamp as receiving history, not proof of enclosure readiness. During storage, I coordinate weather protection, keep piles within the applicable height limit, and maintain stability with the required supporting means. I keep scrap with protruding nails reasonably cleared from work areas and travel paths while framing continues. Before installation, I site the members. I identify crown, bow, cup, twist, and other warp before the piece disappears into the assembly. I install horizontal members with crown up. I orient usable wall stud crowns consistently so the wall plane does not alternate from one direction to the other. Before enclosure, I stop relying on appearance. I use a probe type or contact type moisture meter. I measure 2 feet to 4 feet from the grade stamped end. I take at least 3 random readings on wall and floor framing. I document the results in a format acceptable to the enforcing agency. If framing exceeds 19%, I do not cover it. If insulation is visibly wet, I replace it or allow it to dry before enclosure. That sequence is useful because each decision happens while correction is still practical. Delivery is the time to catch the wrong material. Open framing is the time to catch distortion and orientation. Pre-enclosure is the time to verify moisture. After finishes are installed, the same mistake becomes a removal and repair problem. I also want you to notice the shared principle across the episode. Moisture, crown orientation, stable storage, and housekeeping all protect the next operation. The next operation should not inherit a condition that could have been identified earlier. That is, General B supervision in plain language. I do not need to perform every trade task personally to know when the work is ready to advance. Here is the final memory check. 19 is the enclosure gate. 2 feet to 4 feet is the reading location from the grade stamped end. 3 is the minimum number of random readings. The stamp tells me then, and the meter tells me now. Warp is the family term. Crown is edgewise, bow is flatwise, cup is across the face, and twist wins the corners. Horizontal members go crown up. Wall stud crowns face the same direction. 16 feet is the manual stack limit. 20 feet is the overall pile limit, and every pile still has to remain stable. Scrap lumber with protruding nails stays reasonably cleared from work areas, passageways, and stairs. These are testable concepts based on the published Contractor State License Board study outline and the source-backed California material in this lesson. I want you to use the numbers as decision points, not isolated trivia. Ask what condition is being measured, when it is being measured, and what operation is about to happen next. There is an audio practice quiz for this specific episode. It is audio-based with the questions read aloud, and you answer by tapping, so it is built for people studying while driving, working, or on the go. Go to the description below this video. You will see a link that says Pass the CSLB. Tap it. It will take you straight there. Comment below with any questions about framing moisture, storage, crowns, or warping. Subscribe to stay on track through every episode until you get your license. I know you are fitting this study work around real jobs and real responsibilities, and I am here to help you make every session count.